Hey y'all, Jonnalee here, improving number sense. The $1 million answer to so many questions we have in math education. Why is it that some students appear to have a strong number sense, other students have a weak number sense? That's for another video. But today's session is going to be about how do we improve the number sense, no matter where kids are. What is the intervention? What is the process? What is the cycle? Today's process is called the numeracy cycle. The numeracy cycle is exactly as it sounds. It is a cycle that we continue to loop infinitely, over and over again, in all grade levels to improve the sense of number. So today's topic, numeracy cycle. This is an introduction to the numeracy cycle. We will go in depth with each one in some other videos, but today we're going to lay out the foundation of what the numeracy cycle is and just a little bit of definition of each of the components. There are 4 components to the numeracy cycle. 4 ways that we can improve number sense. So if students are struggling with number or really many things in mathematics, it's going to go back to one of these 4 components. There is sort of a hierarchy or a progression in these components. Typically, I like the whole chicken and egg idea. It doesn't matter which one comes first, second, or third. And it really doesn't in this cycle as well. But the most important action that we can take in the classroom, the most important action that we can have kids do to have a huge impact on how well they understand numbers is counting. That's it. It's as simple as that. Now, we can make counting very complex, and we will get into that, some in this video, some in some other videos. But the number 1 component for improving number sense, the first component in the numeracy cycle, the first step in improving student sense of number is count. And when I talk about counting, there's lots of different levels of counting, but initially we just want kids to rote count. We want kids to sing-song count without any meaning. They do this as toddlers all the time. 2, 4, 6, 8, who do we appreciate? Kiddos start to skip count by tens, 10, 20, 30, 40, 50, 60. However, once kids get to 60 and I ask them to continue to count by tens, here's what typically happens for some of the littles: 60, 70, 80, 90, 100, 101, 102, 103, 104, which is not counting by tens anymore, but it really tells us a lot early on about a student's understanding of number. I do have some littles that'll start at 60 and count by tens and do it correctly. 60, 70, 80, 90, 100, 110, 120, 130. So kids at every age, at every level, have a range of understanding of number. Our first task often is to figure out where they are on that continuum or where they are in that range. One way that I can assess that is with counting exercises. A couple other counting exercises I have kiddos do as kids get a little bit older is let's skip count by tens, but start at 24. 24, 34, 44, 54, etc. Kiddos as young as 6 or 7 years old can do this. It's not typical, but they can. So I like to push that with those littles. Older students, 10, 11, 12, 13 years old, sometimes will struggle doing this. So I want us to think outside of grade level or school level or age level, and I want us to just extract where kids are as far as level of understanding of number. And these are some exercises that I use to assess that. These are also exercises that I have students do over and over again to improve their rote counting, which then will improve the second component of the numeracy cycle, which is what we really want them to have a strong understanding of, and that is quantify. Quantify. Now, when students are rote counting, I said that they could rote count without meaning. They can rote count with meaning. But rote counting without meaning means that kiddos don't have this skill of being able to quantify. Now, what is quantify? It means that they know the value of the number. They're counting meaninglessly if they don't know the value of the number, but they're counting meaningful if they know the value of the number. What do I mean by value of the number? How large or small the number is. Another word for that is the magnitude of numbers. Magnitude of numbers is knowing how large or small a number is, and more specifically, and this is pretty advanced, pretty abstract, where the placement is of the number on the number line. Often with some of our younger students, we teach number line as a tool for improving number sense. But we want to do that in reverse. It's a little counterintuitive. We want to use exercises through the numeracy cycle to improve number sense in order for students to better place numbers on the number line. The number line is really one of the most abstract, complex tasks we could have kids do. If kids understand number line and where numbers are placed, that indicates that they have a strong sense of number. If they don't understand number line, which is very typical, they shouldn't. It's very abstract and complex. That means that they have a middle or low sense of number. So what we want to do is we want to improve their sense of number through the numeracy cycle. Lots of exercises with rote counting to build on understanding quantity and value of numbers. Then students will get better at placement of numbers on the number line. Now, a little aside, because I can't ever just teach in a linear way, math teaching and learning is very nonlinear. One of the barriers to student long-term learning is when we continue to teach consistently in a linear way, step by step, one thing at a time. We want to break away from that if we're talking about conceptual development or improving number sense. If we're teaching procedures and algorithms and quick facts, recipes, formulas, step-by-step processes, then we want to be exactly linear. But when we're talking about things like improving number sense or the sense of numbers or this innate understanding of how numbers work, operate, and compare to each other, we want to give kids experiences rather than a linear step-by-step approach. There are two camps of mathematics. You can see this in some of the other videos. There's the procedural camp and the conceptual camp. I won't get into that too much now, but when I'm talking about improving number sense in the numeracy cycle, I'm mostly talking about improving the conceptual camp, but you'll see in just a moment, boom, we're gonna hit the procedural algorithmic with our fourth step and component of the numeracy cycle. So once kids start to understand the value and the magnitude of numbers, then we can move to this next stage of the numeracy cycle, which is compare. So I really know this one number really well. So now I can add another number to it and start to compare these two numbers. Which one is larger? Which one is smaller? And that is the third step in the numeracy cycle. Compare. The fourth step in the numeracy cycle is operate. This is many times where we spend the most time in our classrooms, is students operating, add, subtract, multiply, and divide. Now, I like two other operations, exponents and roots, but that's for another time. Operations meaning typically add, subtract, multiply, and divide. That is what we prioritize many times. We want kids to get really good at that skill, but we need to understand that some kids are really good at that and other kids are not. So the question is, how do we improve students' ability to be better at operating, adding, subtracting, multiplying, dividing? So let's put the fourth component here, and then I'll explain it and answer that question. Operate. That is the fourth and final component in the numeracy cycle. So when we are having students operate, add, subtract, multiply, and divide, if they are struggling with algorithms or procedures or with mental math or the conceptual understanding, we can take them backwards in the numeracy cycle. So if this is where the student struggle is, the two numbers that I'm having them operate, I'm going to go back and say, you know what, let's get rid of the addition, subtraction, multiplication, division symbol, and let's just look at the two numbers. Let's compare the two numbers. My favorite three words, tell me about. I use these words to gain a student perspective. A number of times, what we do in intervention when we're trying to fill gaps with students is we continue to give our perspective over and over and over and over, and then we hope it sinks into the students. That's not how we improve their innate sense of number. That's not how we improve their understanding of much of anything, by telling and giving our perspective. So if I'm backing up in the numeracy cycle because students are struggling, the last thing I want to do is give more of my perspective. What I want to do is gain more of their perspective, so then I can lead them in the right direction for their next best step. So for example, I have the two numbers and I'm going to ask students to tell me about my favorite three words, tell me about. This makes me back up as a facilitator, as an instructor, and say, look, your perspective isn't important right now. Their perspective is, and my best prompt for gaining their perspective is tell me about. Tell me about these two numbers. What can you tell me? What do you notice? What do you see? And I just continue to try to dig and let them say anything they can about those two numbers. Once they say things about those two numbers, I'm going to document what they say. I'm going to repeat back what they say. If I have other students that I'm working with, I'm going to ask the other students, what do you think about what they said? What can you tell me about those numbers? Now, let's suppose my students are struggling with the comparing. If they're struggling with the comparing, I can back up to the previous component of the numeracy cycle, which is quantify, understanding the value and magnitude of a number, how big or small. So here I was comparing two numbers. What I'm going to do is I'm going to narrow it down to one of those numbers. I'm going to pick one of those numbers and say, my favorite three words, tell me about this particular number. What do you see? What do you notice? Here's another great prompt. How can we write that number in 20 different ways? 20 ways is the name of that prompt. I use it often. So if I'm going to ask students to quantify, I'm going to say to them, write this number in 20 different ways. Now, if they are struggling with writing that number in 20 different ways, I will ask another prompt, one of my other favorite prompts to gain student perspective. Show me a picture of this number. Now, let's suppose students are also struggling with this. Well, here's the key. We go back to the first component of the numeracy cycle, and we have students rote count by numbers close to these numbers that we're dealing with. Now, I didn't tell you what numbers we were dealing with here, and I did that on purpose because oftentimes, and I guess I could gain your perspective if we were interacting live together, but oftentimes we think maybe of the number that is a part of our course, or the number that we deal with most often in the course that we teach, or the level that we teach. So we could use this with any type of number. That's the point of all of this. We spend much time with students rote counting when we're dealing with whole numbers. And so students gain a much better understanding of whole numbers than they do fraction and decimal, and even integers. So what I'm asking us to do is, when we move into other number systems, other categories of numbers, other types of numbers, fractions, decimals, we don't leave out this rote counting piece. We start with so much rote counting, and then kids are going to be more successful in each of these other components. But if they're struggling with all of them, if I've gone backwards far enough that I'm rote counting, if I'm dealing with whole numbers, let's suppose we're operating with the numbers 92 plus 48, let's say. Well, we're comparing 92 and 48. Well, let's just look at 92. Now let's count by ones around the number 92. And hey, let's count backwards. Let's count backwards from 102. 102, 101, 100, 99, 98, 97, 96, 95, 94, 93, 92, 91, 90, 89, 87, 86, 85. Well, if I'm adding 48 and 92, I could count backwards to 48. Is that addition? See, I can really build some conceptual understanding here with some of these exercises. Some students might say, well, why did you start at 102 and count backwards? Well, I wanted to see if you knew how to count backwards from 102. It's one of my exercises for assessment. Many times when I'm instructing and facilitating, we have instruction, we have assessment going on at the same time. I call it instructment. That's exactly what I'm modeling here today in kind of an artificial way as I'm telling you about it, which is not exactly how I would facilitate with my students, but I would give kids these rote counting exercises to help them understand how big or small numbers are. Well, if I'm counting backwards from 102 and I get to 92, and then it takes me a while to get to 48, 48 must be a lot less than 92. But if I'm operating, how do I operate with 92 plus 48 in counting backwards? Where would I have to count backwards from? I know these questions sound really weird, and you might be thinking, Jonalie, why are you going in all this roundabout? It's because I'm not focusing on procedures and algorithms right now. Not that that's not important. It is absolutely essential. I want kids to understand procedures and algorithms, but here's the point. If they're struggling, I have to go back and facilitate instructional strategies, instructment strategies, such that I can instruct and assess at the same time, like some of the examples I'm giving. Go back far enough, do some of these exercises to build their innate conceptual understanding of number. Then I can move it to these procedures that they're struggling with. What we oftentimes do in intervention is we repeat the procedures and the algorithms over and over and over to get more interactions. And we can do that. Many students just need more interactions over time, but it doesn't fill in some of those conceptual gaps that are going to continue to plague these students as they move through the grades. If I fill in some of these conceptual gaps, as students get to other types of numbers, they're going to have a stronger relationship with those numbers and be able to do all of these things much better than what they did with whole numbers. So for example, if I'm operating 3/4 plus 7/8, and students are struggling, I can go back. Let's compare 3/4 and 7/8. Well, what do? I don't start delivering information. I use my favorite 3 words. Tell me about 3/4 and 7/8. Gain the student perspective. If they're struggling with that, I go back to quantify. Well, let's just look at 3/4 for a moment. Tell me about 3/4. What do you see? What do you notice? How big or small is 3/4? Where might that be on a number line? Let's just start to understand the magnitude of that. If they're struggling with that, this is where we go back to rote counting. Rote counting is the key, is the foundation of improving number sense. If students are struggling whole class, we can do this. If students are struggling, I can pull them for intervention. I'm going to focus on rote counting. Yes, rote counting by fraction. I might have students rote count by 1/4 or even 3/4. If I have students count by 1/4, we're going to count 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Sometimes I'll write that down. Sometimes I won't. Sometimes I'll use a model. Sometimes I won't. Those lessons are for another time. But I just want kids to be able to rote count verbally, mentally. We can do it as a whole group, small groups, or individually. Rote counting is the key, the foundation, and step 1 of the numeracy cycle. We will go into depth with more of these. This is just an introduction of the numeracy cycle, but it is the foundation. It is the pre-lesson for many other tasks and exercises that I'm going to be doing on these videos. But here is the numeracy cycle. The biggest intent is to improve students' understanding of number, to improve number sense conceptually, but also eventually procedurally. The numeracy cycle has 4 components, 4 parts: count, quantify, compare, operate. Thanks for listening. We'll see you soon.